Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 282. Page 282, and today is our lesson number 102. The problem that we are going to work on is problem number 80. Please turn to page 282 and read the problem number 80 to yourself. We are told that R and S are positive integers. R and S are positive integers. The question simply is, can the fraction R over S, can the fraction R divided by S be expressed as a decimal with a finite number of non-zero digits? With a finite number of non-zero digits. For example, 100 over 4, of course, can be expressed, 100 over 4 was not, can be expressed as a finite number of 100 over 4 was not a good example. 100 over 3, for example, or 10 over 3 for that matter, or better yet, just 1 over 3, cannot be expressed as a finite number of non-zero digits, because this goes on forever, 0.333 forever and ever. But if you have something like 2/5, that can be expressed as a finite number of non-zero digits. You get the idea. The question simply is, can this fraction be expressed as a decimal with a finite number of non-zero digits? In the first statement, they tell us that S is a factor of 100. S is a factor of 100, which is the bottom part. The denominator is a factor of 100. So what are the factors of 100? That's the first thing we have to understand and we have to answer. What are all the factors of 100? Because it says S is a factor of 100. They don't know which one. They don't tell us which one. So we have to enumerate all of them. Factors of 100 are 2, 4, 5, 10, 20, 25, 50, 100. I left out 1. Which means the fraction in question could be R over 2, because you see R is on the top, so it could be R over 2, or R over 4, or R over 5, or R over 10, R over 20, R over 25, R over 50, or R over 100. Now what we have to realize at this point is that it doesn't matter what the numerator is, it doesn't matter what the top is. If you take any number at all, and if you divide it by 2, any number at all, it will have a finite number of non-zero decimals, because basically you're cutting it in half. If you divide something by 2, you're cutting it in half. So it doesn't matter what the number is. You can divide 7 by 2, you can divide 13 by 2, you can divide 5 by 2, you can divide 2414 by 2. It doesn't matter what it is. It will have a finite number of non-zero decimals. Similarly, if you divide something by 4, you're essentially taking 1/4 of it, and again it will have a finite number of decimal points. Same thing with dividing by 5 is taking a 20% of something, or 10% of something, or a 5% of something, or a 4% of something. Dividing something by 50 is simply taking 2% of something. So whatever that number is, you move the decimal places by 2 places, and that gives you 1%, multiplied by 2, and you will have your 2%. It will have the finite number of non-zero decimals. So it doesn't matter what R is here. Therefore, it says, regardless of what value R takes, the fraction can be expressed as a decimal with finite non-zero digits. 1 by itself is enough. 1 by itself, statement 1, does provide sufficient information to answer the question. The question was, can this fraction be expressed as a decimal with finite number of non-zero digits? The answer is yes. A, D, B, C, E. Since the first statement by itself is enough, we know that the answer cannot be B, C, or E. It will have to be either A or a D. If it turns out the second statement is also enough by itself, then the answer would be D, otherwise A. Let's look at second statement. In the second statement, they tell us exact same thing, except now they tell us for the top guy, the numerator, they tell us that r is a factor of 100. Again, if r is a factor of 100, then the possible fractions are, rather, yes, r is a factor of 100, r is your top here, therefore the possible fractions are 2 over s, or 4 over s, or 5 over s, or 10 over s, or 20 over s, or 25 over s, or 50 over s, or 100 over s. Here, what's going to happen is that depending on what value s takes, we don't know what s is, we have no idea what s is, depending on what value s takes, this fraction that we're looking at, may or may not have a finite non-zero digits. For example, 2 over 3, if s happens to be 3, 2 over 3 has infinite number of non-zero decimal places because it never ends. It's just 0.666666 forever and ever. Amen. On the other hand, if s happens to be 5, then 2 over 5 of course has finite non-zero decimal places because it's just 0.4. So we don't know what s is. Without knowing the value of the s, we cannot tell if this fraction, any of these fractions, will end up having a finite or infinite number of decimal places. Therefore, statement number two is not enough, and hence the answer is A. The answer is A. And that's all. That's it. I'll see you tomorrow, okay? Bye now.